Hello everyone, my name is Pedram. I'm a professor in economics and finance, and I'm also a CFA charter holder. This is another episode of my crash course in machine learning concepts, Simply Explained. Part 1, Machine Learning versus Statistical Learning, the big picture. Alright, so in this episode, I'm going to walk you through the difference between the machine learning world and the statistical learning world from the other hand. Let's begin with the big picture. So, what are we trying to do as a researcher or a practitioner? Eventually, at the end of the day, we want to solve some real-world problems by answering some specific questions, right? Sometimes we need to either make an inference about a bunch of hypotheses, or sometimes we need to make simply predictions. And for those questions, for those real-world problems, sometimes there's a theory, and most of the times there's absolutely no underlying theory. Let me walk you through a bunch of examples and it makes more sense. Okay, so imagine in marketing, we're interested to see what is the relationship between sales and advertisement, right? What's the relationship between sales from one hand and advertisement, R&D expenditure, seasonality, industry type, and etc. from other hand. So this is a really interesting question. Or for example, you want to work as an economist for big name companies like Amazon, Google, Microsoft, Apple, and then basically you want to quantify the demand function, right? So you're interested to see what is the relationship between quantity demanded from one hand and price, income, technology, price of competitors, the price of substitute from the other hand, right? So this is also another type of interesting research question. And then finally, for example, you want to see what's the relationship between wage and education, age, gender, industry, job characteristic, and etc. Right? These are all really interesting research questions. Maybe for the quantity demanded ones, you have a beautiful, perfect underlying theory. But for the rest of the questions, there's not necessarily a theory. So we have to start from the data, right? Whatever the question is, we have to start from the data. We have to and see, depending on the data, the type of the data set, we will end up working with either a machine learning model or an econometric model. So it all narrows down to the type of the data set that you're working with, and more importantly, what's your end goal? What do you want to do with that question? All right. So now let's look at a couple of more examples in more detail to see what I mean by type of data sets and what's your goal as a practitioner or a researcher. All right, so let's begin with a very simple example. Imagine we want to quantify someone's wage components, right? And what are the drivers? The drivers can be some skill set and demographic variables like education, age, experience, IQ, or it can be some social and cultural profile variables like ethnicity, race, gender, or it could be simply some job characteristic variables like industry, location, working hours, and etc., right? Whatever the variables are, you need to build a model, right? If there's an underlying theory between wage and all these characteristics, then you can leverage from the theory and start making a model from the theory. But if in this example, when there is no underlying theory between wage and all these characteristics, at least as of today, then you should start by making some assumption, right? So you can say, okay, let's assume that there is a linear functional form between wage and all these characteristics, right? Then we can summarize the relationship like this. We can say that, okay, wage is a function of education, age, experience, IQ, and etc., right? And we can come up with this simple linear functional form. So the questions that you should ask yourself then is that, can you interpret this model, right? And more importantly, do you care about interpretability? So what does that mean? It means that, for example, at the end of the day, do you care what's the coefficient of education, right? Is it economically and statistically significant or not, right? If that's kind of the question that you're interested in, then you're more willing to get some inference out of predictions, right? So here it says that, okay, you're looking for some inference versus prediction. Because at the end of the day, if this coefficient turns out to be significant, then you're going to say that, okay, so it seems that education, the partial effect of education on wage is significant, holding everything else constant. So what does that imply? It implies that for you as a policymaker, maybe you're going to say that, okay, we have to dedicate this amount of budget to the state for education because the model shows that it matters, the data shows that it matters, right? And from the other hand, let's see, can you make predictions using this model, right? And again, more importantly, do you care about making predictions, right? So for example, did you collect the survey data to, at the end of the day, make some predictions for other people's wage? If that's the case, then you're caring more about predictions versus interpretability, right? Versus making inferences. So this idea of which goal is more significant, it all goes back to you as a researcher. Sometimes you want to become a storyteller, you want to act as a policymaker. So in those cases, you cannot care less about making predictions, right? So you don't care that, okay, I want to come up with a model that make predictions for wage. I want to come up with a model that I can infer something from that. So if that's the case, so your goal is to making inference. However, on the other hand, if you want to make predictions, if you purely are using this data, this model to make some predictions for some other people's wage, then your goal is to make predictions, right? So I want you to pay attention to these two terms. So this is going to help us a lot in terms of understanding what's the difference between machine learning and econometrics. So interpretation versus prediction. All right. Okay, now let's look at a different example. This is what we call image recognition, right? So for example, you're given a bunch of pictures and you want to classify them as cats versus dog, right? Where should we start? Is there an underlying theory? How can we model this thing, right? So in this example, I want you to specifically think about this question. At the end of the day, do you really care about interpretability of the model here, right? So do you really care how does this model go from taking the picture and giving you at the end of the day, okay, is it a cat or not, right? So the output is it a cat or not? Do you really care how did that happen? And basically, can you interpret these things, right? So most probably the answer is no. And another question that I want you to think about is, what about accuracy of your prediction? The answer is absolutely yes, right? At the end of the day, you want to come up with a model that if you give it some information, it will eventually be able to tell you if it is a dog or cat, right? So for example, if you pass to the model this picture, it better tells you that, okay, the answer is dog. If you give it this picture, the answer is dog, and etc., right? This picture, the answer is cat. So you do care about predictability of this model a lot versus interpretability. So the difference between these two examples that I provided is that in the first one, wage versus education one, we cared about interpretability because we wanted to become a storyteller. We wanted to say that, okay, what's the effect of right-hand side variables on the left-hand side variables? In the second example, in this image recognition example, we could not care less about interpretability. There's nothing to interpret. At the end of the day, we want to make some predictions, right? So these two simple questions are going to help us a lot in terms of understanding what is the difference between machine learning and econometrics or statistical learning. All right. Let's see if we can summarize those previous examples in a more formal way. What is the difference between statistical learning and machine learning? I'm going to go ahead and write those examples up here again. So for the statistical learning, we were doing the wage inference, right? So we want to see what are the ingredients of the wage and how they impacted the wage. For the machine learning, we looked at the wage prediction. If you're purely interested in to see how we can predict wages, predictions, that example, and the image recognition. Okay, so in the previous examples, if you were purely interested into making predictions, we were dealing with machine learning models. And if you wanted to make some inference, we are dealing with the statistical learning models, right? Now let's focus on the differences. So the first thing, focus on of attention, right? So in the statistical learning, we are interested in hypothesis testing and interpretability. This is a key term. We want to become a storyteller. We want to see what is the relationship between variables, right? In the machine learning world, we care about predictability, right? So what's the accuracy of the model? At the end of the day, we don't care about interpretability that much, right? It's not zero, but we don't care that much about interpretability. For the statistical learning, what are the drivers? The drivers are math, sometimes theory, and most of the times hypothesis, right? So you have an idea, you want to test that idea, you have some hypothesis. So you come up with a model and you try to see what's the relationship between variables. In machine learning, it's all about fitting the data, right? Give me some data and I'm going to tell you what's the relationship between variables, and not necessarily I'm interested in making those inferences, but I will tell you what are the predictions, right? Data size. In a statistical learning, the data can be any reasonable data set. So for example, a data set of 30 observations cross-sectional might be enough, right? However, in machine learning, it's all about big data, right? Those three V's, volume, velocity, and variety, right? So in terms of volume, we're talking about millions or sometimes 100 millions of records. Velocity, in machine learning, we're talking about real-term or near real-time data set, right? We're talking about seconds, milliseconds, etc. And when it comes to variety, so this is important, the variety of the data. Let's actually explore it in a separate row. So when it comes to the data type, in statistical learning, we are dealing with structured data, right? So the data sets that we can simply summarize it in nice columns and rows, right? So for example, we have wage, we have education, we have gender, and etc. So this is what we call flat file, right? So we can have a table. However, in machine learning, we deal with structured data, so simply like this wage data set, unstructured data, and semi-structured data. So the unstructured data, the examples of are like those images, voices, and videos, and etc., right? Text. And semi-structured data are a combination of structured and unstructured. For example, I don't know, the images on your cell phone, right? The image itself is unstructured, but the location and time of that photo that you've taken is going to be the structured part. So it's going to be a combination of the two. Okay, so this is very, very important because remember, guys, if your data is unstructured or semi-structured, you can simply not use the statistical learning models. You cannot use the econometrics model. You have to use machine learning models. So this is a big deal. Why? Because as of today, you know, more than 80% of the data out there is going to be unstructured, and only 20% or even less than that is going to be structured. So this means that for more than 80% of the real questions out there, you cannot, right? Guys, remember, you cannot use a statistical learning. You cannot use econometrics, and you have to use machine learning, right? Then the next feature that we're going to explore is dimension or scalability, right? So for statistical learning, we're dealing with mostly low dimensional data because we want to keep the model simple. We want to keep it interpretable. Remember, it's all about interpretability. If I make the model more flexible, if I increase the dimension of the data to hundreds, 200s, 300s, or thousands, then it's not easy to interpret things, right? It's not easy to hypothetically hold everything else constant and see what's the net effect of one variable on the other ones, right? So basically in econometrics, in statistical learning world, we try to keep the dimension of the data very low. However, on the other hand, in machine learning, it's all about predictions, right? Give me as many predicting factors as possible. So we are dealing with high dimensional data, and sometimes we are talking about the dimensions of 100,000s, millions even. In neural networks, we're dealing with millions of dimensions, right? Okay, then the next one is model choice. So in statistical learning, we are interested in parameter significance and mostly in sample goodness of fit, right? Because remember, this is at the end of the day, you want to make inference using one data set. You're not trying to make prediction, right? So you don't necessarily need to divide the data set into train and test set. Basically, using your train set, you want to see how the model is doing a good job or a bad job, right? And we are interested in parameter significance. We want to see that, for example, if the effect of education, if the parameter, that beta 1, was significant or not, statistically and economically. However, in machine learning, we are interested in to make predictions, right? So for that reason, we're going to divide the data into train set and test set, right? And at the end of the day, we want to see what's the accuracy of the data in that test set, right? And we're going to do that by something called cross-validation. We will talk about it in the next series. Then the next one is interpretability. So this is a big deal. This is a big one. This is a big distinguishing factor between statistical learning and machine learning. Remember, in statistical learning, the interpretability is high because the model is designed to perform that way. And in machine learning, the interpretability is low because, again, it's designed to be that way. You know, you make the model so flexible in order to capture, in order to make better predictions, but it comes at a cost. The cost is that your model is less interpretable. And then finally, let's look at the strength point of each of these models. So for statistical learning model, the model hopefully understand the causal relationship and behavior. And I say hopefully because, you know, correlation does not necessarily mean causation. So we have to make a bunch of assumptions. And if all those assumptions are valid, then we can say, okay, now we can think of it as causality versus correlation. And the strength point of the machine learning model is just its prediction, right? Because again, in the machine learning world, we are more interested in making predictions. It's all about nowcasting, and today, more recently, we forecasting and nowcasting. So nowcasting basically means that just use the real data, right? Real term data. All right. Okay, now with the previous slide in mind, let's go over a more complex example. And let's see if we are going to use an econometric model or a machine learning model or a combination of the two. Okay, so let's look at this Apple stock price prediction. So this is an example in, let's say, finance. At the end of the day, we want to predict what's the price of Apple going forward, Apple stock going forward. So what are the classical drivers? So the drivers are going to be companies fundamental, like balance sheet, income statement, cash flow statement, and out of those statements, we are going to be able to come up with some financial ratios, right? For example, price over earnings and etc., price over sales. Then what are some other classical drivers? Basically, we're going to look at the competitors. We're going to find something called the comparing multiples. So for example, comparing the price over earnings of Apple with Microsoft, with, I don't know, Google. So, and we're going to see that which company has a higher PE or which company has a lower PE. And then those are going to be the factors of making predictions for the price of Apple, right? So what are some other classical drivers? Technical analysis. We can look at the moving averages. We can look at the, I don't know, average true ranges and some other technical indicators, so we can leverage on those things as well. And then finally, we can look at some seasonality, right? So for example, the holidays, the month, days effect, January effect, December effect when it comes to asset pricing, right? So these are all classical drivers. So what does that mean? It means that we can use, first of all, look at the type of the data set. So is it going to be a structured or unstructured? What do you think? So yeah, these are structured data, right? So it means that we can summarize the data in a nice table. We have rows and columns, right? If that's the case, we can either use econometrics or statistical learning, or we can use machine learning. So far, I can use either of them. I can, if the goal is to interpret things, I can use econometrics. But if the goal is to make predictions, I can use machine learning, right? So what do you think here? Here, most probably we are more interested into making some predictions, right? So we're going to say that, okay, we're going to put more weight on the machine learning side rather than econometrics now, right? Now let's continue and see what are some other drivers of the Apple stock market price. And for example, let's see. Let's look at this new information. Market sentiments, right? Like news, tweets, blogger opinion, conference calls, right? So what about these ones? What do you think? What's the type of these data? News, tweets, and opinion, conference calls, and etc. These are unstructured, right? And because these are unstructured data, this means that we can only use machine learning. So the econometric is out of reach, right? So basically, econometrics or statistical learning cannot use this data set to come up with some making some predictions, right? So we have to use machine learning. What are other drivers? So for other drivers, we can think of, look at that, we can think of satellite images from Apple Store parking lots, right? Isn't it interesting? So for example, instead of waiting 1 quarter to look at the sales number, we can look at the satellite images from the Apple Store parking lot and see, okay, make a prediction about the sales in real time, right? This is important, in real time, or whatever delay that the satellite images come with. So we are not going to wait a quarter and wait for the quarterly data or wait for the conference calls to see what were the sales. We can see these numbers in real time. So this is more of a nowcasting thing, right? Instead of forecasting. So these are really interesting data that we know that they're all unstructured and we have to use machine learning for that, okay? So guys, here I'm not trying to say which one is better. I'm not trying to say that if an econometric model is better or a machine learning model is better. Actually, I want you to learn both. But what matters more importantly is that you understand what's the difference between the two. Sometimes, if you're dealing with this kind of unstructured or semi-structured data sets, the answer is simply machine learning because this is out of reach for econometrics. Sometimes, however, you're dealing with a structured data and you have to make a decision. Do you want to work with a simple model? And by simple, I mean less complex and be able to interpret things? If that's the case, use econometrics. Or if you want to make pure predictions, and if in that case, you're going to do machine learning, right? At the end of the day, you should use them together. Imagine you're working for a team in a company, and then you want to make these kind of predictions. Remember, at the end of the day, if a client sits in front of you and you want to say that, okay, the portfolio lost $1 million, you should have some reason for that, right? You cannot say that, okay, we use a black box and the black box wanted us to do this, and because of that, we lost $1 million. So it's not good. You want to have some explainability as well, right? So because when you sit in front of a client, you want to see what exactly happened. So for that purpose, you want to work with an econometric model. But at the same time, you want to increase the accuracy of that econometric model. So why not combining it with some machine learning tools and techniques? So that's the takeaway, okay? So with that, let's conclude this episode by the question of the day. Okay, here's the question. Imagine you're dealing with two real-world problems, right? Number one, the question that you have is, you're more interested in making predictions, right? You do care about inference, but you care more about making predictions. Which model should you use? Should you use an econometric model or a statistical learning model or a machine learning model, right? So guys, I use a statistical learning and econometric model interchangeably because basically they are part of the statistical learning model and the machine learning model from the other hand, right? So which one do you use, machine learning or statistical learning? Situation number two, you're dealing with a real-world problem that you're more interested into making inferences. You want to become a storyteller, right? You want to be able to relate variables with each other, and you're interested in more interpretability, making inferences versus prediction. You are also interested, guys, remember, you are interested in making predictions, but not as much as making inferences, right? So which one do you use, machine learning or statistical learning? So I want you to write down your answers in the comment sections. You can also make a discussion that why you should think of a combination of the two, right? Okay, with that, I'll leave you with that and I'll see you in the next episode.